Today we will discuss one very important topic of the binomial theorem, which is the binomial series, and there are different categories in this binomial series. It means different categories of sums in this series, and to solve the IIT JEE question we have to know some fundamental series. So let's start. 1 plus x whole to the power n is nc0 plus nc1 x plus nc2 x square plus nc3 x cube ncn x to the power n. In this case, if we put x equal to 1, if we put x equal to 1, we are getting 2 to the power n equal to nc0 plus nc1 plus nc2 plus nc3 ncn. So 2 to the power n equal to nc0 plus nc1 plus nc2 plus nc3 continuation up to ncn. It means if it is 3c0 plus 3c1 plus 3c2 plus 3c3, that is 2 to the power 3. If it is n minus 1 c0, n minus 1 c1, n minus 1 c2, n minus 1 cn minus 1, this is 2 to the power n minus 1. In this way, now putting different values, we are getting different series, and which you have to keep in mind. These are the fundamental series. To solve the JEE examinations sum, we have to remember all these things. Now put x equal to minus 1 in this, in 1 plus x whole to the power n, we are getting 0, 1 minus 1, it means 0 equal to c0 minus c1 plus c2 minus c3, so minus 1 to the power n cn. If we take the negative part to the left hand side, so c1 plus c3 plus c5 equal to c0 plus c2 plus c4. Now this is, let us consider this is to be number 2. Now from 1 and 2, instead of, so it means c1 means nc1, c3 means nc3, c5 means, I am writing in short. So instead of c1 plus c3 plus c5 in this number 1 equation, if we put c0 plus c2 plus c4, so there are two number of nc0, two number of nc2. So from this we can write this as nc0 plus 2 number of nc2 plus nc4 equal to 2 to the power n. Therefore this can be written as nc0 plus nc2 plus nc4 equal to 2 to the power n minus 1. Similarly, using the 2, we can get nc1 plus nc3 plus nc5 equal to 2 to the power n minus 1. So if I give one example on this, we are getting n minus 2 c1 plus n minus 2 c3 plus n minus 2 c5 equal to, in this 2 to the power n minus 1, instead of n, let us replace n minus 2. So this is coming 2 to the power n minus 3. Now in 1 plus x whole to the power n, in place of x, let us put I. So put x equal to I in 1 plus x whole to the power n. So 1 plus I whole to the power n, that is nc0. So instead of nc0, nc1, so I am writing in short c0, c1, c2, c3. So c0 plus c1 I plus c2 I square plus c3 I cube plus c4 I to the power 4 continuation. That is coming to be c0 plus I c1 minus c2 minus I c3 plus c4. So in this left hand side, if we multiply by 1 by root 2, our target is to apply the cos theta plus I sin theta whole to the power n in De Moivre's theorem. So we are getting 2 to the power n by 2 and cos n pi by 4 plus I sin n pi by 4. According to the De Moivre's theorem, n is coming to the angle, this power will come to the angle. Therefore, putting this, we are getting here C0 minus C2 plus C4 plus I into C1 minus C3 plus C5. So if we equate the real and imaginary part, and if we separate, we are getting the another series, and these are the fundamental series. These are extremely important for the entrance examination. So we can write this as 2 to the power n by 2 cos n pi by 4 equal to C0 minus C2 plus C4. Continuation, let us give it the name. This formula is the formula number 3, this formula is the formula number 4, and 2 to the power n by 2 sin n pi by 4 equal to C1 minus C3 plus C5. So this is 5. And now we can see one thing, that is C0 plus C2 plus C4 continuation equal to 2 to the power n minus 1, and C0 minus C2 plus C4 continuation equal to 2 to the power n by 2 cos n pi by 4. So if we add this C0, C2, C4, this portion, if we add this part and this formula number 4, we are getting here, if we add these two, we are getting C2, C6, they are getting cancelled, and we are getting two number of C0 plus C4 plus C8 equal to, in this case, 2 to the power n minus 1 plus 2 to the power n by 2 cos n pi by 4, and if we divide by 2, it means just I am taking these 2 to the denominator, we are getting here C0. So we are getting another one equal to 2 to the power n minus 1 plus 2 to the power n by 2 cos n pi by 4 divided by 2. So this is 6. Now again, if we just subtract these two, we are getting what? C2 plus C6 like this. If we subtract these two, we are getting C2 plus C6 plus C10 equal to 2 to the power n minus 1 minus 2 to the power n by 2 and cos n pi by 4 divided by 2. This is 7. In this way, we are getting the, if we add this 5 and 2 to the power n minus 1, it means C1 plus C3 plus C5, and in this case plus 2 to the power n by 2 sin n pi by 4. If we add, we are getting C1 plus C5 plus C9. In this way, we will get one more series. So these are the fundamental series which we have to keep in mind in solving the entrance examination paper. Now I am starting application of this with some series and some IIT questions. In this sum, this is C1, it means NC1, C1 means NC1, C3 means NC3. Okay, so in this case you have to prove C1 plus 2 C2 plus 3 C3 continuation, this equal to n into 2 to the power n minus 1. Let us use the calculus, so it will be easier for us to solve the sums and we can solve in the shortest possible way. So let us start with 1 plus x whole to the power n, that is C0 plus C1x plus C2x square Cn x to the power n. So since C0 is not present, we know that on differentiation, if we differentiate, then C0 constant, the derivative of the constant is coming to be 0. Therefore, we can write this as, we can take the differentiation of this. So if we differentiate with respect to x, it is getting n into 1 plus x whole to the power n minus 1, and if we differentiate, the derivative of C0 it's a constant number, its derivative is 0, and this is c1x, this is derivative is c1 plus 2c2 x square. In this way n cn x to the power n minus 1. Therefore, put x equal to 1. We are getting, I am writing this as the first. So, c1 plus 2c2, putting x equal to 1. We are putting on the both side x equal to 1. We are getting c1 plus 2c2 plus 3c3. So, n cn equal to n into 2 to the power n minus 1. So, let us go to the another sum. In this sum, c0 plus 2c1, it means when the coefficient in applying the calculus, when the coefficient is coming outside, it is a differentiation. When the coefficient is a divided part in the denominator, it should be generally integration. So, in this case we are seeing that c0 is c0 plus 2c1 plus 3c2, c0 exists, it means we cannot differentiate directly. So, let us start with the sum. 1 plus x whole to the power n, that is c0 plus c1x plus c2x square plus c3 x cube cn x to the power n. In generally, in all the series, sum should start with 1 plus x whole to the power n whenever series is general case, but there are some exception also. Therefore, ready, let us start with this. Since c0 exists, multiply both sides by x. So, we are getting this c0x plus c1x square plus c2x cube cn x to the power n plus 1. Therefore, differentiating by UV formula. In this case, we are multiplying by x because c0 exists here. Otherwise, if we differentiate, the constant term would be 0. Okay. In this case, let us differentiate with UV formula. So, u constant derivative of v plus 1 plus x whole to the power n constant, derivative of x is 1, and the derivative of c0x is c0, 2c1x plus 3c2x square. In this way n plus 1 cn x to the power n minus 1. Now put x equal to 1. By putting x equal to 1, we are saying n into 2 to the power n, 1 plus 1 2, 2 to the power n minus 1 plus 2 to the power n equal to c0 plus 2c1 plus 3c2 n plus 1 cn. Now, if we calculate, if we take 2 to the power n minus 1 common, we are getting our requirement. So, 2 to the power n minus 1 into n plus 2, we are getting c0 plus 2c1 plus 3c2. In this way, we can prove it. It means we have to see if the coefficient is coming outside. In general case, there are a lot of exceptional cases there, as well as there are different categories of sums are there. So, in this case, we are seeing that since the coefficient is coming outside, it is a differentiation. Let us go to the next sum. c0 plus 3c1 plus 5c2 into continuation 2n plus 1. Generally, what to do? First of all, before doing differentiation, in this term we have to see this term coefficient of cn. Why? Because in case of coefficient of cn, it is the power of x to the power n. So, power of x to the power n should be 2n plus 1. What we have to do? Just keeping similarity with all this term. So, let us start with 1 plus x whole to the power n, that is c0 plus c1x plus c2x square. Continuation, instead of x, let us put x square. So, 1 plus x square whole to the power n, that is c0 plus c1x square, because in place of x square, in place of x we are replacing x square. So, instead of x we are putting x square. So, c1x square plus c2x to the power 4 plus c3x to the power 6, continuation cn x to the power 2n. But in the question it is c0 present. Therefore, we have to multiply both sides by x. Otherwise, if we differentiate, the C0 will becoming 0. Derivative of constant is 0. Therefore, let us multiply by x on the both sides. We are getting x square whole to the power n, that is C0x plus C1 x cube plus C2 x to the power 5. So, Cn x to the power 2n plus 1. Now, in this case, it is in the form of uv. So, differentiate by uv form. We are getting x constant, derivative of 1 plus x square to the power n, that is n into 1 plus x square whole to the power n minus 1 into derivative of 1 is 0, x square is 2x plus 1 plus x square whole to the power n, and the derivative of x is coming to be 1. Now, C0x, the derivative is C0, 3c1 x square, 5c2 x to the power 4. So, 2n plus 1 cn x to the power 2n. So, the purpose is served. Now, put x equal to 1. So, putting x equal to 1, we are getting n into 2 to the power n minus 1 into 2 plus 2 to the power n equal to C0 plus 3c1 plus 5c2. So, 2n plus 1 cn. Therefore, n plus 1 into 2 to the power n equal to C0 plus 3c1 plus 5c2. So, hence is the proof. It means we have seen that if the coefficient is coming outside, generally we have to differentiate, and if the coefficient is coming down, because if we just integrate x to the power n, so x to the power n plus 1, denominator x plus 1, and if we differentiate x to the power n, this is n x to the power n minus 1. So, one more example. In this case, it is in the denominator. So, let us integrate. So, the starting point is 1 plus x whole to the power n. It is coming C0 plus C1x plus C2x square. So, Cn x to the power n. Integrate between 0 to 1. So, 0 to 1, we are getting, after integration, we have to apply the upper limit and lower limit. In this case, lower limit is 0 and upper limit is 1. Therefore, here it is coming 1 plus x whole to the power n plus 1 by n plus 1. 0 to 1 equal to C0 x plus C1 x square by 2 plus C3. In this case, it will be C2. This is C2 x cube by 3. So, Cn x to the power n plus 1 by n plus 1. Now, if we apply upper limit and lower limit, in this case, just see one thing, if we put x equal to 1, this is 2 to the power n plus 1, upper limit minus lower limit is x equal to 0. So, we are getting here 2 to the power n plus 1 minus 1 by n plus 1, that is C0 plus C1 by 2 plus C2 by 3. So, Cn by n plus 1. It means, in general case, if in the denominator there is a coefficient, so we have to integrate. It will be easier for us to understand. If we, once again, for differentiation, if coefficient is outside in the numerator, we have to do the differentiation, and if the coefficient is in the denominator, general case, we have to apply the integration. So, I am going some another example. This type of sum is very common in entrance examination. So, how to solve this type of sums, and you have to keep in mind that this type of sums, whenever it will be coming. Just see one thing, here the denominator, that is NCR, this R part, that is, if you sum this R plus 0, that is R minus 1 plus 1, that is R minus 2 plus 2. So, this is a particular type, particular category, and very important for any examinations. So, how to solve this type of sum? First of all, 1 plus x whole to the power m. Let us calculate. So, C0 mc0 plus mc1x plus mc2x square MCR x to the power r into x to the power m. And if we take another series 1 plus x whole to the power n, we are getting nc0 plus nc1x plus nc2x square. So in this case final is x to the power n. If we multiply the two series, we are getting, we are getting here 1 plus x whole to the power m plus n. So this is coming mc0 plus mc1 x plus mc2x square. So mcr x to the power r x to the power, this is coming x to the power m, which is multiplied by into nc0 plus nc1x plus nc2x square. So x to the power n. This is the identity. In this identity, let us equate the coefficient of r on the both sides. We will get this. Remember, it is extremely important how to count, how to remember this thing. In this case, so if this NCR, this RCR part is the constant, in this case r plus 0 r, r minus 1 plus 1 r. So if the r part is the constant, we have to apply this method. So equating the coefficients of x to the power r on the both sides, we are getting m plus n cr, and we are getting here mcr into nc0. So just see, this is mcr, this portion is mcr, this is nc0, and this is mcr minus 1 into nc1. So if it is r minus 1, in this case the previous term mcr minus 1 x to the power r minus 1, it means x to the power r minus 1 into x to the power r. Its previous term mcr minus 2, it is x square. So we have to take the coefficient of x to the power r on the both sides. We are getting our requirement series. Continuation mc0 ncr. If it is mc0, and here the, if we just see the last term mc0, because we'll come back for the m and we'll go front for the n. So if we see the last term mc0, and in this case ncr present here, ncr into x to the power r. So if we take the common x to the power r, this is the coefficients of x to the power r. So let us equate on the both sides. So this is the value of, this is m plus n cr, and this is very important series we have to keep in mind while application. Okay, in this case the sum of the r should be constant. One more such example I am showing you. This is one previous JEE question. This is one previous JEE question. So in this case 30C0, 30C10 minus 30C1, 30C11. So it is not matching. It is not matching that previous case, that the sum of the r should be constant. But we know that NCR equal to NCn minus r. NCR equal to NCn minus r. It means terms are equidistant. Therefore, in this case we can write this as the series is 30C0, 30C n minus r. It means 30 minus 10, it means 20, minus 30C1, 30C, 30 minus 11, 30 minus 11 is 19. So in this way 30C20, 30 minus 30, that is 0. So 30C30 equal to also 30C0. So 30C0. Therefore, in this case, if we add the coefficients, same as this previous r. If we add the r, it is coming to be constant. Whenever it is, we have to apply our previous, but alternative sign is there, plus minus sign is there. Under this case, what we have to do? Just see. We have to take the, it is the coefficient, above is the coefficient of x to the power 20, coefficient of x to the power 20, this is 30, x to the power 20 in 1 plus x whole to the power 30 into 1 minus x whole to the power 30. It means this is coming to be 1 minus x square whole to the power 30. How to get the, where to get the coefficient of x to the power 20? Here. Just see one thing here. To find the x to the power 20, we have to apply 30c 10. So the answer of this question is 30c 10. Let us go to some IIT JEE question. It means JEE Advanced recent years questions. This is the IIT question 2016. Integer type. So what is written? Let us see. Let m be the smallest positive integer such that the coefficient of x square in the expansion of 1 plus x whole square 1 plus x whole cube up to, this is 3n plus 1 into 51c3. Find the value of n. So how to solve the sum? We are saying that 1 plus x whole square to 1 plus x whole to the power 49, this is the GP series. So it has 48 terms. So let us solve it. Let us make the GP. So in this case, 1 plus x whole square into a into r to the power n minus 1 by 1 plus x minus 1. This can be written as, and this is also I forgot to write this another term, plus 1 plus mx whole to the power 50. So in this case, if we apply 1 plus x whole square into 1 plus x whole to the power 48 minus 1 by x plus 1 plus mx whole to the power 50. So in this case the coefficient of x to the power, we have to search x, coefficient of x square. So let us write again. This is coming 1 plus x whole to the power 50 minus 1 plus x whole square divided by x plus 1 plus mx whole to the power 50. So in this case, the coefficient of x to the power 2 means we have to take the coefficient of x in 1 plus x whole to the power 50. We have to take coefficient of x to the power 3 because divided by x. So we are writing as 3n plus 1 according to the condition, 3n plus 1 into 51c3 equal to, here it is the coefficient of x to the power 50, coefficient of x to the power 3 it is because divided by x. So we are getting here 50c, coefficient of x to the power 3 is 50c 3 plus, in this case coefficient of x to the power 2 is 50c2 into m square. Now we can write this as 3n plus 1 in equal to 50c3 by 51c3 plus 50c2 by 51c3 m square. In this case, we can write this as 50c3 by 51c3, that is ncr by n plus 1 cr. We can write this as n minus r plus 1 by r n plus 1 in this case. So r plus 1 by n plus 1, it means we are getting here 2 plus 1 by 51 m square according to the question. Therefore we can write this as, here n equal to 50, therefore 50 minus 3 plus 1 by 50 plus 1 plus 3 by 51, it means 1 by 17 m square. We can write this as 50 plus 1, 51 minus 3, 48, 48 by 51. It means 48 by 51, how to cancel here? So if we divide by 3, 16 by 17 plus 1 by 17 m. Now according to the question we can write this as 3n plus 1 equal to 16 by 17 plus 1 by 17 m. So n equal to m square minus 1. If we calculate here, if we divide by 3, if we calculate here, m square minus 1 by 51. It means least positive values of n for which m is there. Therefore, if we take m square 51, 51 2s are 102, so not possible. But if we put m square 51 3, not coming. And if we put m equal to 16, 16 square is 256, 256 minus 1 is 255. In this way we have to put the different values of m, and we are getting we have to be satisfied, so that we will get the minimum value of n. If we put m equal to 5, m equal to 6, it is not getting cancelled because it is a multiple of, we have to get multiple of 51 in the numerator. So if we take m equal to 16, 16 square is 256, 256 minus 1 is 255. So 255 by 51. So n is getting m equal to 16, for which n equal to 5. And therefore, in this case the value of n is 5. So let us do some another question of IIT examination. This is the question of JEE Advanced 2018, integer type. So in this case, let x equal to 10c1 whole square plus 2 into 10c2 whole square plus 3 into 10c3 whole square. So it is following some series. So let us write the series in the summation form. After that we will see what can be done. So this can be written as x equal to summation of r equal to 1 to 10 r into 10 cr whole square. So let us make some calculative series so that the thing is totally comfortable to us, our known series. So we can write this as r into 10 cr into 10 cr. So r into 10 cr can be written as r into 10 factorial by r factorial into 10 minus r factorial. This can be written as r into 10 into 9 factorial by r into r minus 1 factorial into 10 minus r factorial. So if we calculate, and we are saying that this is 10 into 9c r minus 1 is coming. This is coming 9c r minus 1. So let us put here, we are getting, therefore x equal to summation of r equal to 1 to 10 r into 10 cr. We can write this as 10 is outside, I am writing. So 9c r minus 1 into 10c 10 minus r, because we know that ncr equal to nc n minus r. And let us expand. If we expand the series, we are getting here 10 outside. So if we put r equal to 1, 9c 0 into 10c. If we put r equal to 1, so 10c 9. If we put r equal to 2, 9c 1 into 10c 8. In this way, if we put the last term, we put r equal to 10, so 9c 9 and 10c 0. So we have done this, that the sum of the r, this ncr, sum of the r term is constant. It means it is the coefficient of x to the power 9. So this is equal to 10 into coefficient of x to the power 9 in 1 plus x whole to the power 9 plus 10, 19. So this is coming 10 into 19 C9. Now our target is we have to get the value of x by 1413. So x by 1430 equal to, put the value of x, 10 into 19 C9 by 1430. So we can write this as 10 into 19 factorial by 9 factorial into 19 minus 9, 10 factorial into 1430. So let us calculate here. So 19 into 17 into 16 by 8. This is coming 19 into 34, that is coming 646. Therefore, this is the sum we have solved. It means this type of lot of different category sums are coming in binomial theorem, and I will make lot of such videos. So